Welcome to Did You Know? The ESCO HVAC Show. We will see you in about 45 seconds or so. Make sure that you are subscribing to our channels, our LinkedIn, YouTube, Facebook. Turn on notifications, and we are very excited to be here with you. It's almost time, about 30 more seconds. Make sure to grab your notebook and pen so you can jot down notes along the way, because at the end of the show, you could have an opportunity to ask our guests questions so we can dive a little deeper into these topics. And here we go. Welcome to Did You Know? The ESCO HVAC Show. Well, welcome everyone. We are so glad that you are joining Did You Know? The ESCO HVAC Show. You know, there was a time not too long ago when an HVAC contractor could go to a structure, do a load calculation for that, do a duct design, and then select the equipment and have a very efficient running system in heating and cooling. Now, as the industry is starting to develop into more inverter and variable capacity driven systems, we're starting to have a variety of issues that we need to become more aware of when it comes to capacity, both in heating and cooling, and when it comes to the comfort level, especially when we're looking at dehumidification. Now, one of the fears of all contractors is to walk into a scenario where a homeowner says, hey, we just installed a new sunroom on the home, and well, it's not really keeping up with the system anymore, and we're going to have to shut the doors on this space. And now we need to decide what we can do with the rest of it. Can I tie into my existing duct system? Or, you know, I've also been looking at things and I found, you know, these $500 mini split systems that were online. Will that work for my HVAC system? Well, really it comes down to now we're going to have to do a proper load calculation and start looking at the demand of the system and evaluating whether our equipment has the capability of maintaining our space. I ran into a similar scenario myself. When I moved into this new home, I had an oversized garage that was unfinished. Perfect thing for a guy like me who hoards everything manly. So many tools and motorcycle and all woodworking and all sorts of scenarios. So there were things that I was taking into consideration. I needed to be able to have a comfortable space, both in heating and in cooling, but also I needed to be concerned with dehumidification. In the wood shop, which is the back area, it was going to be a dedicated space so that I could maintain some humidity in that area. Now, in the front part of the garage, I had the concern of a water heater. So really not the best scenario to have a new home with a water heater in the garage, but it is common in my area. So looking at the design of my system, I had to be able to evaluate how I can maintain different spaces and then select equipment that was appropriate for what I was trying to do. When I started doing load calculations, I could see that my main concern was keeping that water heater comfortable, right? Keeping it around 40 degrees at maybe a 0-degree ambient. And then I also had humidity concerns to take a look at for the space in the back. Now, as I started looking at equipment, I found that there was a wide range of capable equipment that could handle heating and cooling capacities, but not all could handle them in the lower temperatures that I needed. And that was a learning curve to look at equipment to go, okay, I need capacity. In this particular scenario, I was looking for around 6,500 BTUs at 0 degrees ambient. So when I looked at two equipment, I was looking at these two particular ones. These are both 3-ton units because I needed in the lower 30,000 BTUs at about 47 degrees ambient. So I was needing a 3-ton unit. Most of these inverter-driven systems are jumping between tonnages. So I'm going between 2 and 3 ton. I didn't have a 2.5. So in comparing our two different 3-ton units, the one on the right, if we look at the rating for it, it had a heating capacity of about 9,100 BTUs. That's the 9.10. And that was at its lowest heating capability. The thing that we have to do is to make sure that we're looking at our expanded data tables for the equipment that we are selecting to make sure that it has complete capability for our selection. This particular heat pump, 9,100 BTUs, that was at 5 degrees. And this particular heat pump would actually shut off at 5 degrees and no longer has the capability of maintaining below that. The one on the left, it's rated at 6.60. That's 6,600 BTUs. But this piece of equipment is rated at minus 13 degrees Fahrenheit. So for my particular scenario, I was concerned with BTUs at lower capabilities, but it's not the only concern that we have to look at when we are selecting equipment. And that's what we're here today, is to talk about some of the things to take into consideration to make sure our equipment has the capability, not only for comfort cooling, but for comfort in general, especially when we're looking at humidification and dehumidification functionality. Now, one of the companies in the industry that has been around the longest time dealing with contractor concerns with equipment design and selection is ACCA. ACCA has been around for over 100 years. And today we're here to talk about equipment selection using Manual S. And Ed, I am so grateful that you are here with us today. You're just such a fantastic person, and we're grateful to have this ability to share this educational experience in the industry and to bring our technicians, bring our contractors into a better understanding of how the industry is changing and where to go to get the resources to be the best that they can be. So I am really, really grateful for your time today.
Oh, well, thanks for having me. And one of the things I've got to learn to do is to time this stuff better so my wife can get an earful of what you just started off with, because she doesn't understand why sometimes I can't walk through the doorway because my head's so big. And it's tough when people, you know, introduce you to fanfare like that. So I appreciate the kind words. I've been at this for a while. I've been teaching out of the design series books for a long time, well over 20 years. And I've worked with a lot of utility programs and such. And I go out, or I have gone out is a better way to phrase it, to a lot of jobs where it wasn't broke, it ran, but we had unhappy people, right? Exactly. And my job was always to figure out what was wrong.
That's it. And
it's always the same thing, over and over and over. The ductwork leaks too much. You're familiar with duct testing, right? Where you the duct blaster, you hook it up, and
we're actually going to be doing that later in the season. We'll have a live demonstration to talk about some of that.
Excellent, and that's way too involved. I do the watch test. Are you familiar with the watch test?
I am.
You have your watch on, you go and find a gap in the ductwork up in the attic or down in the crawl space, and you shove your hand in, and it goes all the way up to your watch. There's a piece of equipment that's losing 20 or 30% of its capacity right there.
Significant leakage.
Yeah, these houses, it's the same thing over and over and over. We are so laser focused on how many tons the unit is. Yep. And we just look right past the distribution system. And if we don't have a proper distribution system, the system can't function the way it needs to. Right. So it's something that is quite simple. It can't leak, and it has to be big enough to allow the air to pass through it at an acceptable velocity so we can get the proper amount of air coming out, what I like to refer to as the intentional holes in the duct system, right? And they're the supply outlets, and then the air goes back into the returns. So the other part of it too, which we're not really going to talk about today, is making sure the machines are charged properly. And if you even put a little bit of effort into it, it's not difficult. The topic for today with the split systems, really not superheating, subcooling any of that stuff. We're saying 6 pounds, 8 ounces, put it in a scale, shoot it in, walk away from it. You know, it's something I learned. I grew up in I live in New Jersey, and I don't know if people think of New Jersey as a heat pump market, but we had what I like to refer to as the perfect storm for a long time where I live. You take the mid to late 80s, you take people that are very affluent and wealthy from the northern part of the state. They grew up in turn of the last century housing. So they had big hunks of cast iron radiation in their living room and throughout the house.
Lots of cubic space.
And they were used to having radiators that radiated this nice warm heat. And then they moved down near me, and they bought houses on slabs with heat pumps, and the heat was blowing out of the ceilings, and whoever was doing in the designs wasn't doing a good job. And these people were very unhappy. So they would say, it needs Freon. So we got very good at, and this is pre-608 stuff. We dumped the charge. I had a dial a charge. And if anybody's familiar with that product,
got one on the shelf.
Put it in, plug it in, put the
heater up, let it roll.
9 ounces in it, and we know it's charged right. And then the people were still angry because they were cold because it was not a good system. We're like, well, the heat pump's working the way it's supposed to. Right. So that was one of those things. Maybe they did follow the guidance that's in all those books that's up on the screen right now, or maybe they didn't. But I know a lot of those houses now have hot water baseboard in them. So it's kind of, I'd say it's going to be a typical story for my area, but that's how it goes.
Absolutely.
I let the cat out of the barn. Go back one. We'll talk about the design series real quickly. We have a lot of books. We have a lot of books that will guide the practitioner or the designer. I like the word practitioner because that's what's been in the books for a long time.
Sure.
And there's 3 books that you'll find referenced in codes. Yes. And that's going to be J, S, and D. Everything else is a really good suggestion. I was just dealing with a problem house. Well, the Friday before a holiday weekend, that's 3 o'clock. That's when you want people to call, right? And the cool thing about this job now is I don't have manual J emergencies. You know, I can wait until after the weekend. But that being said, we have some ideas being floated by the homeowner, and some of those ideas, 4 to 6 degree difference floor to floor, that's actually something you can find in manual RS. That's going to be in the top column under residential. Or
ACCA residential manuals in system concept.
System concepts. And when I do my 3-day class, which is J, S, D, and T, I always recommend people purchase that, 1 copy for each company, and hand it out through everybody in the company. And you can get some good ideas of ways that you can accomplish comfort on residential systems. But it's got this chart in it, and it starts with expectations. And if we don't zone in multi-level houses, it's expected to see some big discrepancies. So the JS and D are standards that are referenced in code. And when somebody wants to talk about being specific with temperatures, it's not a standard, it's a book, but it's based off of math and what our expectations really should be.
That's right.
The one that's missing in the design series, from my perspective in the code book, is Manual T. Manual T is a book that gives us guidance on picking grills and registers. And it really doesn't have anything to do with aesthetics. It has everything to do with performance. And I would say 80 to 90% of the contractors or practitioners that I speak to and I start asking about how they select grills and registers, you get the hands in pockets and looking at the floor, avoiding eye contact. And I was there at one point too, but now I understand it and I see what a big difference it can potentially make. So it's something we should pay attention to. Absolutely. In the commercial columns, light commercial is a focus of that design series. The duct design in Q is different than the duct design in D, although we're still going to use a duct wheel. It's just the order that we essentially do that is different, is the best way to put it. So now we can jump by. There it is. One of the biggest beefs I have with contractors who will dig their heels in about their 400 or 500 square foot per ton, whatever their magic number is. I'm amazed at how many people are very adamant about that being a thing. Right. We've got people that are building good houses. We have contractors that are doing good designs. And I see it on social media, and I'm not, I can't control myself sometimes. So I'll be friendly, I'll be courteous, but I have no problems telling somebody that they're wrong.
Right, absolutely.
Because there are people that you'll get somebody out there that's their house is 1,500 square foot per ton, and they maintain temperature. They have realistic expectations and they're maintaining comfortable conditions, and people will just flat out tell them it won't work. And that goes back to measuring things.
Right.
Anybody who has ever gone through the learning curve of measuring airflow knows the frustration of how difficult it can be trying to get repeatable results. And once you come to the realization that there's a lot of ways to estimate airflow, but very few ways to actually measure airflow.
To correctly measure.
Yeah, and there's stuff out there now that as long as you know the difference between the supply and the return, and you can drill a hole without drilling a hole in the coil, anybody can measure airflow. I don't know if you're familiar with the True Flow grid, but that is something that very neat piece of equipment.
Very intriguing.
Yes, very helpful. And it's something that maybe you're not going to spend the money on that, but you have your other ways. Well, you compare how you're doing it to that, and that is, you know, our starting point, or our, you know, it's going to give us our number that we can rely on. Right. So that works out pretty well. So when we talk about Manual J, the next part of it is going to be Manual S, and what's on the screen right there. Manual S gives us guidance for selecting an indoor coil, a blower size, and a piece of equipment to match it to. And one of the things that people tend to forget, and I use that picture of the traditional looking outdoor unit there versus what looks like a traditional mini split. Mm-hmm. Mini splits rely on the same set of rules, if you will, as a traditional unitary split. When airflow is lower, well, they're going to dehumidify better. When airflow is higher, they're going to give us more sensible and more total BTUs. And sometimes we have control over that, and sometimes we don't. And the biggest problem I personally see out there in today's market is people just automatically assume that 1 ton or 2 ton mini split technology piece of equipment is going to do a fabulous job of conditioning that space. Right. And it's not the equipment's fault. Something got lost in the mix. Somebody wasn't paying attention. Somebody didn't do, you were showing about your expanded performance data that you had to hit a certain number. Well, we got to look in that expanded performance data to anticipate the kind of performance we're going to actually get out of the equipment. Far too many people in our industry talk about sizes with respect to tons, and that's not how we should be looking at air conditioning equipment. Manual S also addresses hot air furnaces. It also addresses boilers. And I'm going to brag for just a second. That is, yeah, please do. Yeah, that's about 30 feet or 40 feet away from where I'm sitting right now.
Really?
Yeah, we have cold enough winters to justify putting the heat in the floor. And I walk around barefoot all winter. My office is in an unfinished basement, and it doesn't change in temperature, maybe but 2 degrees year round.
Very nice.
Dry. It doesn't stink. A lot of basements, you know,
sure.
They get kind of funky. I don't have that issue at all.
A lot of proper design and equipment selection. Yes,
it has everything to do with it. My humidity doesn't really fluctuate more than 15% in the basement. Never, it doesn't hit 50 because I do have a regular roll around dehumidifier down here. And it does get a little bit drier in the wintertime, but very comfortable. This is the money shot, if you will. This is one of my favorite slides to talk about, because if anybody who is watching this right now, if the only thing you get out of this is, well, I got a cool boiler, and you understand what sensible heat ratio is, it will be your friend for life.
Correct.
Understanding what equipment does when we manipulate airflow, I've called it the keys to the kingdom for a long time. There's way too many people out there trying to troubleshoot equipment that don't have a fundamental understanding of the properties of air. So 2 things. Get a psychrometric chart. I don't have to get that fancy. Get an app on your phone that has something to do with looking at wet bulb temperatures, dry bulb temperatures, and dew points. And start to acclimate with those numbers. So you go in somebody's house and it feels disgusting, it's got a 66 or 7 or 70 degree wet bulb temperature, compared to a 60 to 62 degree wet bulb temperature where you might actually feel chilly. Because I love having people come in my house. I got some fancy equipment in my house. I got a couple of 2-stage geothermal heat pumps. We keep our thermostats at 75 or 77 on any given day.
Under controllable humidity conditions. Absolutely.
I'm in my basement. I'm below grade right now, and my RH right now is 40%. And it rained today. My equipment doesn't run that much, but it runs enough to dehumidify the space, and it's nice and comfy. So back to the slide at hand. Sensible heat ratio is a numerical expression showing how much work our piece of equipment will do per hour, right? BTUH per hour.
Amount of work over time.
Yep. And it divvies that up over how much work the equipment's going to do to drop the temperature of the air. And we call those sensible BTUs. And how much work the equipment's going to do to take the evaporator coil down below dew point and get water to condense on it and then run out the white pipe. I mean, that's ultimately what we want to have happen. In the example on the screen, that's a 10,000 BTU unit. And if you're going to tell me that doesn't exist, I'm going to say it does. And it's a Fred's unit right there in front of you.
All right.
So it's 10K. I picked a sensible heat ratio of 0.75. And I picked 0.75 because if you took your favorite unitary split, 14, 15 SEER, standard piece of equipment, and ran it at that magic 400 CFM per ton, it would produce a sensible heat ratio around 0.7.
Of approximately.
Yeah, it might be up to 0.77. It might be down to 0.73.
Sure.
But a real
That's the fundamental design behind it.
Yeah, yeah. And I'm ballpark rule of thumb. I'm not against those things as long as they come from good mathematical practices, but that's what we're talking about here. And we got a piece of equipment that's 75% or 7,500 BTUs of its total capacity is dropping the temperature of the air. The other 2,500, remaining 2,500 BTUs are condensing water vapor out of the air. Now, the cool thing about this, and you can try this at home if you really want, or if you don't want people to talk to you at the barbecue, look for the white pipe dripping out of the house, get your red Solo cup, and
start measuring.
Yeah, 1,000 BTUs is going to fill up a red Solo cup, 16 ounces. Pint is a pound kind of a thing.
Yep.
This stuff's all math. None of this is conjecture. It's all fact.
Validated.
And you can measure this stuff if you want to. And being able to measure this stuff makes it so that we can make systems work better. You have somebody that's complaining about their system is not able to control the temperature when it's really hot out. The definition of really hot out for me is above a design day. Well, increase their airflow. That might get you that couple of degrees that they're complaining about.
Sure.
The flip side, you have a house where the people are saying, I feel kind of sticky. Well, check that airflow. If it's higher than necessary, lower it, and it's going to dehumidify better.
Correct.
So under the 2,500 on the bullet points there, it says manipulate airflow and our sensible heat ratio changes. This is what the guidance in Manual S is all about. It's going to tell us to pick equipment that meets the sensible, meets the latent, doesn't exceed the total by 15, 20, or 30% based off the compressor technology. So single stage equipment, 15% is our max. Two-stage equipment, 20% is our max. And our VRV stuff, 30% is our max. What happens with the equipment when we run higher airflow, more total capacity, more sensible capacity, we see sensible heat ratios that can eclipse 0.8, maybe even higher. The flip side, less airflow, we're going to see that sensible heat ratio decrease. We're going to see a lower sensible capacity, a lower total capacity. We're going to see an increase in latent capacity, which can be beneficial. High sensible heat ratio, more efficient. Low sensible heat ratio, less efficient. And that is exactly the specific reason that we don't arbitrarily say, I'm going to run it at the lowest airflow that this thing will run at. Because if you arbitrarily run a system at a lower airflow than necessary, you're taking money out of the people's pockets that are paying their utility bills.
Sure.
So that's something to keep in mind. We also have to remember that equipment as well as the structure has a sensible heat ratio. And to make that a little bit easier to understand moving forward, we're going to start seeing sensible heat factor replacing sensible heat ratio with equipment.
I was going to ask about that.
Yeah, and sensible heat ratio is going to stick with homes.
Okay.
I believe it was one of the mini split manufacturers that already started publishing sensible heat factor, and they were involved. Oh, it was Kimberly was the one I believe brought it up, and she said we should do this in Manual S to for less confusion.
Coincide with it. Sure.
It's going to be 20 years before I'll be able to stop saying it's sensible heat ratio for equipment is sensible heat ratio factor, but it's a good move to start moving in that direction to make separation between the two terms.
So do you think we'll see more of that in the expanded data from equipment manufacturers?
Oh, yeah, without question.
As we should, because it kind of falls back into the play where we're looking at the capacity of the equipment that is being selected. Can it do the work that I need for it to do and at different operating conditions? So it really adds into the factor of calculating how much work can be done by this piece of equipment, because we're going to see that all over the place as we get into variable technology, just like you're talking about with the inverters and VRVs.
That leads me right into Manual S is in the current state of being updated. And although it does address the two-stage and VRV equipment with the higher tolerance for acceptable wiggle room above the gain on the structure,
right?
We got a whole new set of rules coming out. When if you're in a dry climate, and I'm paraphrasing, but it says do whatever you want. If you can create a dry climate condition, which essentially is if you have VRV equipment and the manufacturer publishes its very low speed operating performance, then as long as we can guarantee our latent removal, you can put a bigger piece of equipment in.
Absolutely, because then we're going to be working on sensible heat and changing the calculation.
But the whole thing comes back to on non-design days, we got to be able to maintain humidity. In fact, when I was talking to this gentleman that's having an issue Tuesday, I was explaining to him, to be very blunt, and I was kind of harsh when I said it, I don't care about the operating characteristics of an air conditioner on a hot day, on a design day, because it's running. It's going to dehumidify. The temperature might go up a degree or 3, but you're going to be well under that 50% RH target. So if it's 77, but I'm at 43% RH, I still got a 62-degree wet bulb, and you should be comfortable. Quit staring at the thermostat.
Right.
What I care about is 85 degrees in gray, 82 degrees in gray. Because if I don't have the runtime, I can't get the moisture out of the house.
That's exactly right.
We are, as an industry, far too focused on the wrong thing. So that's the way that all works out. Finish up my thought on updates to S. There's going to be a dry sizing condition that we can create with ancillary dehumidification. So if you want to put a dehumidifier in, you can create essentially any environment you want. Solid chance you're going to be able to heat that house with your heat pump as long as you take care of the moisture in the summertime. All right.
Absolutely.
Real simple. We've been dancing around, so to speak, expanded performance data. We spoke about what happens to equipment performance as we slow the air down. If you look all the way to the right, the top box says 850. To your left, 800. To your left, 750. That's the manufacturer telling us what a 024 and an 030 match together. That's a nominal 2-ton outdoor unit matched with a nominal 2.5-ton coil together at 75 degrees at 50% relative humidity in the expanded performance data. Under the 850, it says 7562 at 75 degrees at 50% relative humidity. If you follow that down to the next box, the top number is telling us our total capacity at 85 degrees outside. That's just a random outdoor temperature.
23,000 BTUs.
Right. So it's 23,400 BTUs of total capacity. The box below it is sensible capacity. And if you deduct the 19K from the 23.4, we get 4,400 BTUs of latent capacity. That's the way you extract the three values that are required for proper equipment expanded performance data. See a trend as we move to the left, as we slow the air down, we're going to see a decrease in total capacity, a decrease in sensible capacity, and an increase in latent capacity. Just the way the slide before talked about sensible heat ratio, that's the math. That's showing you that I'm not full of soup.
Right. Absolutely.
And that's a good way to say that.
Yeah, so no, it's a matter of plugging numbers.
Yeah, it's math. And you know, the thing we get, I've probably done, without exaggeration, 150 or so manual S classes over the years. We had a utility program where it was a requirement to show your math with the manual S process, and we did like one a month for 3 years or something. So I've done a lot of classes on manual S. So people would come in and they would be very intimidated, and I'd see them 2 months later and they're telling me stories about how they're standing at the counter at the supply house talking to the tech next to them going, hey, what's your sensible heat ratio?
That's exactly right. How well is your equipment actually performing? Do you know?
Yeah. And I actually do. I'm kind of, shocker, I'm kind of a weirdo at stuff, but I use these little Govee digital hygrometers.
Absolutely.
You get 3 for $21 on Black Friday or whatever it was, Tech Tuesday. I have one in the attic, and I can compare the data from my attic to what's in Manual J, and it's spot on.
Wow.
I have one in the supply outlet in the master bathroom on the first floor because it's closest to the plenum. I can look at my Ecobee thermostat, so I can get my enthalpy for
return supply and outdoor. Yeah.
And then I can do the enthalpy for the supply air. I know I have 538 CFM on low speed out of this piece of equipment, so I can do a real-time capacity test when I'm doing a Zoomy or whatever, and people are like, there's something wrong with you, Ed. And I'm like,
no. That is the quirks of being in the industry and being good at what you do. That's why we really enjoyed having you here with us today.
It's one of those things. Why put gauges on a piece of equipment if you don't have to?
If you don't know what's happening.
You can measure the performance of a piece of equipment, or you know, a close facsimile thereof. There's some more heavy math if you really want to get into it, or there's plenty of apps out there to use. So it's a good way to do it. Yeah,
we're actually going to do a class later in the season where we talk about doing gaugeless diagnostics, because I think it's very critical. If you understand temperatures and humidities, you can determine exactly what your system is doing and be able to calculate capacity of that system. So we might have to come back and regroup on that one again, because that is some really, really good topics to dive into. We'll get into the temperature differentials and wet bulbs of air. Well, we can do the same things with refrigerants.
And how poor of a metric sensible temperature drop on an air conditioner is.
Sure.
Depending on your return conditions. I mean, it's a lot to it. The moral of the story that we are using on this slide right here is more airflow, more BTUs. And I think, do we have a heating slide coming up next? This right here is an example of if you live in a market where you have to populate a balance point worksheet,
which we're starting to do a lot of hybrid systems, a lot of heat pump with electric backup. So a lot of new calculations on doing heat loading.
So those dots are going to be points that we're going to say don't go yet, but in the next slide, from the heating performance data. And I've been on a quest, and this is a question for anybody that is listening now or in the future. I've been on like a 4-year search for where the 450 CFM per ton for airflow requirements for a heat pump originated. Now, I think I know the answer, but I can't find it in any of the ACCA stuff. I have seen it published in some RSCS stuff.
Yeah.
But if you do go to the next slide, if we go and pick any of those dots, let's just take the top dot at 60. And if I go to the left, I see at 70-degree entering air temperature, 28,600 BTUs at 600 CFM for that nominal 2-ton heat pump.
That is right.
And I got a COP, what's it saying, like 351?
3.51.
Right. So if I go to the right under 800 CFM, I see my COP increase, and I see my total BTU output increase.
That's right.
If I go to the right, I see it go up again. So I'm just going to throw it out there that manufacturers for heating, just like for cooling, will generally publish 350, 400, and 450 per nominal ton. You get the most heat out of the highest airflow. And I think that's why that, and it's a rule of thumb because I can't find anywhere else to apply it or where it came from. That's why we see that 450 CFM per ton number associated with heat pumps. Now, you want to know what the proper answer for that is? The closest you can get your heat pump airflow to your cooling airflow, that's the winner. If you're going to end up 400 CFM per ton, run your heat pump there. If you're running at 450, run your heat pump there. At 350, run your heat pump there. The idea behind all that is less monkeying with dampers and more uniform airflow patterns summer and winter.
Absolutely. No, it makes a lot of sense, Ed.
Yeah.
All right.
Hey.
What other topics do we want to cover before we hop out of here? There's a lot of great stuff talking about how we're looking at equipment going forward. There are a lot of things that are changing as we look into electrification and we look into inverter technology and we look at variable capacity systems, because it's not just about the temperature of comfort. It's about the humidity of comfort. It's about that sensible heat ratio and how well our system is performing at different temperatures and how much airflow we actually need for that. A lot of discussions to continue out of that. I really enjoy you being here, Ed. I know this is going to be the start of many fun topics going forward. And I want everyone to know how to continue their education on these topics. Remember, we have changes in every aspect of the HVAC and refrigeration industry right now, in the next few months, and absolutely in the next couple of years. And there's not one source that can handle all of the changes and give all of the proper education to maintain that. That's what we're here to do. We're here to give you the resources of where you need to be in the industry. So if you're a contractor and you're needing to learn more about what is sensible heat ratio, how can I maintain this? How can I study this deeper? There's a lot of opportunities. One is Hey Ed with Ed. So make sure to join in. I know LinkedIn, I watch Hey Ed when it comes through on LinkedIn. Where else can we find that, Ed?
I believe it's popping up on Facebook.
Yeah, being shared on social media.
Social media. And just recently, Alex, she's kind of like my bestie at work. She takes care of all that stuff for me, and she's a giant help with this. In fact, the last round, you can hear a young lady asking me questions. That's Alex.
I did. Awesome.
And she's fun. She's a lot of fun.
Yeah.
And she is corralling me next week. We're going to be in Baltimore for our fall meeting, and another round of these Hey Ed videos are coming up. But she just, we have a landing page on the website now, and you can look at old ones, you can look at new ones, and it's a non-rehearsed thing.
Oh, yeah.
I do not believe any of them have been used with more than there's never been more than one take. No rehearsing, no nothing. We do come up with the questions, and I kind of laughed and I said, in 2 years we can use the same questions because I'll probably give a different answer. But we don't go back and make sure they're right. And I know I got some stuff that probably isn't.
Hey, that's how you and I met. I mean, that's part of the industry, is connecting with the right resources.
Oh, absolutely.
Keeping up to date with changes.
I've been having a lot of fun with the Hey Ed stuff. And I've got some other stuff that's eventually coming out. If I can get a plug in for anything. If anybody wants to learn the design series, really wants to get good at JS, D, and T, at least 4 or 5, sometimes 6 times a year, we will do the 3-day class. I've got one coming up in the Dallas area.
I think, there you go. Oh,
okay.
you got one September 12th, Baltimore, Maryland.
That's next week. If somebody's not that far from the Baltimore area, I'm doing D in a day. We're doing next Monday is an 8-hour manual D. We have in September, last week of September, I'm going to be in Dallas for the 3-day RDIQ, Residential Design Quality Installation. That's the acronyms for, and then that's happening again in November. If you've never been to DC, come to DC and take the 3-day class. The middle day of the class, we meet at the Lincoln Memorial around 6 o'clock, walk the length of the mall, eat bad food out of food trucks down by the Washington Monument.
There you go. That's a good hangout there. Hey, an opportunity to hang out with Hey Ed and get to learn more about things that are going on in the world of ACCA. Well, Ed, I cannot thank you enough for joining us today. There are so many topics that we're going to dive into as we start looking at the HVAC industry as a whole. And we bring in all of these experts throughout the industry, subject matter experts, OEM trainers, and people that are here for the same reason that Ed and I are here, as to help make you better and to help you understand that the world around us is changing and that you have the resources here. And we're going to continue doing this every week. So thank you all for joining us. And we will. It is fun. It's a great opportunity to hang out and just tell the truth and take these things that people look at and go, oh my gosh, another manual that I got to learn because I'm not sizing any system properly. Well, yeah. And if you approach it with that perspective, that's it.
That's
if
what
you
we're all after,
arm yourself with knowledge, how can you lose?
It's the way to do it.
Ed, I love it. Everyone, have a great day, and we will see you next week on Did You Know? The ESCO HVAC show. Oh, and Ed, you got to watch this. You're in this one.
Okay.
Thank you for joining Did You Know? The ESCO HVAC show. You want to see some of these great presenters in person? Well, then we'll see you at the National HVACR Educators Conference, where many of these guests will be presenting live classrooms, and you'll have a chance to interact with them. Would you like to watch this show again? Hey, no problem. Just head on over to YouTube to ESCO Institute. Do you have a topic that needs clarified about some kind of a change in the industry? Well, then let me know. See Beck at escogroup.org and we'll see what we can come up with.